In this video, we're going to learn about operations with radical expressions. We will be looking at adding and subtracting radical expressions, as well as multiplying and dividing radical expressions. Like radicals are expressions that have the same radicand. So the term that's underneath the radical sign is considered the radicand. So an example of like radicals is radical 3 and 5 radical 3. In order to add or subtract, we must have like radicals. In this case, we have 7 radical 2 minus 8 radical 2 because both expressions have a 2 as a radicand. These are considered like terms or like radicals, and we can go ahead and find the difference. So 7 radical 2's minus 8 radical 2's leaves us with a negative 1 radical 2. In this example, when we're asked to add 4 radical 7 and 2 radical 28, we can't begin our work until we have like radicals. So if we look at the first term, 4 radical 7, 7 really has no other factors other than 1 in itself. So this is in simplest form. But radical 28 has a perfect square within that. So let's go ahead and rewrite 2 radical 28 as 2 times radical 4 times radical 7. And what we see happening now is we're going to end up having a like radical, which is radical 7. So let's go ahead and finish simplifying our second term, the 2 radical 28. As we see, 2 times radical 4, well, square root of 4 is 2. So this becomes, we'll leave our 4 radical 7 as is. This is now 2 times 2 radical 7. So now we have 4 radical 7 plus another 4 radical 7. And that all simplifies now to 8 radical 7. In multiplying and dividing radical expressions, we may use the distributive property and then do combining of like terms and or simplifying. Or we may be asked to use FOIL and then simplify. So let's look at a couple examples. In this example, radical 2 needs to be distributed across the quantity radical 6 plus 5. So we will multiply radical 2 times radical 6 and radical 2 times 5, and that becomes radical 2 times 6 plus 5 radical 2, or, in other words, radical 12 plus 5 radical 2. Now we're not finished yet because radical 12 actually has a perfect square within it. So we can rewrite radical 12 as a radical 4 times radical 3, and then our 5 radical 2 is in simplest form. Radical 4 is the equivalent of 2. So this becomes 2 radical 3 plus 5 radical 2. There's no more simplifying that can be done. We do not have like radicals at this point, so this is our final simplified expression. In this next example, we're going to show FOIL of radical expressions. So FOIL, remember, is the product of the first terms. So we'll have radical 6 times 4 radical 3 plus our outer terms, the product of our outer terms, so that's radical 6 times 3 radical 6 plus our inner terms, so that's a negative 2 radical 3 times 4 radical 3. And then finally our last, and that's a negative 2 radical 3. I ran out of room here. Let me squish this in, times a 3 radical 6. So we can clean that up a little bit. And our first product is 4 radical 18 plus our second product becomes 3 radical 36 plus our third product becomes negative 8 radical 9, and then finally our last product becomes negative 6 radical 18. So we're not finished yet. We have some simplifying that we can do. Radical 18 has a perfect square in it, and that's 9. So let's rewrite this as 4 times square root of 9 times square root of 2 plus radical 36, that's 6. So this becomes 3 times 6, or 18. Plus, and here is another perfect square. Square root of 9 is 3. So negative 8 times 3 is a negative 24. And then we have, again, we have a radical 18. So let's rewrite that as a negative 6 times square root of 9 times square root of 2. Okay, let's do a little more simplifying. Radical 9 is 3, so 4 times 3 is 12, and then our radical 2, plus 18 minus 24, and then plus a negative, here again is this is square root of 9 or 3, so negative 6 times 3 is negative 18 radical 2. Okay, now we have some like terms. We have constants here that we can gather up together, and then we have like radicals, which is the radical 2. We have negative 18 radical 2's and a positive 12 radical 2's. That becomes negative 6 radical 2, and then our constant, 18 minus 24 is a negative 6. When we're working with radical expressions and we're asked to simplify, if we have a fraction, we cannot be considered in simplest form if there's a radical in the denominator. So what we do is we've learned to use FFUs, funny forms of 1, in order to get rid of a simple radical expression in the denominator. But we may need to use what we call conjugates. That's if we have like a two-termed radical expression. And conjugates are sums and differences of the same two terms, and we will use those in order to simplify. Because what happens is if we do FOIL using conjugates, because of our opposite terms, we end up dropping out or getting rid of the radical signs. Let's look at an example of that. If we're asked to simplify this expression, negative 3 over radical 10 plus radical 5. So this obviously is not in simplest form because of the radical 10 and the radical 5. So we're going to use a FFU of the conjugate. We're going to multiply the numerator and the denominator by the same conjugate, and that is radical 10 with the opposite sign minus a radical 5. And then we'll do the same on the denominator, radical 10 minus a radical 5. So in the numerator, we simply have a distributive problem. And that then becomes in my numerator, negative 3 radical 10. And then negative 3 times a minus radical 5 becomes a plus 3 radical 5. That's my numerator. The denominator gets a little bit hairy. And so if we do our FOIL, radical 10 times radical 10 plus our outer, radical 10 times negative radical 5 plus our inner radical 10 times a positive radical 5, and then our last, a radical 5 times a negative radical 5. So let's go ahead and leave our numerator as is, negative 3 radical 10 over, or plus 3 radical 5. There's nothing we can simplify with that numerator. Our denominator, though, we're still working on. Radical 10 times radical 10 is radical 100, which is, the square root of 100 is 10. Now, our middle terms here, we have a negative radical 50 and a positive radical 50. So those get eliminated. And we did that because we used these opposite terms when we multiplied by the conjugate. So those middle terms drop out, leaving us without any radical signs. Our last product here, radical 5 times a negative radical 5, is a negative square root of 25. Square root of 25 is 5, so that's minus 5. So our simplest answer then becomes negative 3 radical 10 plus 3 radical 5 all over 10 minus 5, or 5. And that's our simplest term.